Good morning everyone. Welcome to my YouTube channel Research Short Video. I am Dr. Lokesh Gupta. Today we are talking about the standard deviation. If we are talking about the standard deviation is the most stable index of variability. If we say the variability or dispersion, both are the same thing. So there are a lot of measures of variation range, average deviation, quartile deviation. These are the very popular, but yes, most of the in all of these standard deviation is very popular in parametric statistic as well, because parametric statistic is basically based on mean or standard deviation. So that's why parametric statistic or even further advanced analysis is based on mean or standard deviation. So if we are talking about the standard deviation is frequently used in our experimental research and research studies. Most of the time articles we find the mean and standard deviation value. Standard deviation differ from the average deviation. Average deviation is not popularly used in our researches, but yes, average deviation is the only the deviation from mean value, or we just ignore the sign or we disregard the signs of plus and minus. So we consider all signs as a positive, and then we calculate the average deviation from mean value. But important thing is standard deviation is always taken from the mean value. Okay, so in case average deviation and standard deviation is totally different, at that point we just consider, we also manage the sign. So in standard deviation we avoid this difficulty, we just square the separate deviation and after that we divide by n. So this is the basic procedure of calculation of standard deviation. So if we talk about the standard deviation, computing is always from the mean value. We are not taken from that median or mode. So standard deviation is totally based on mean value, and generally we use HD as a short term for standard deviation, and Greek letter sigma is very popular for standard deviation. There are two formulas. First formula is for ungrouped data. This is the sigma x square divided by n. X means the deviation between mean and the our observed score. And the second formula for group data is this is sigma fx square divided by n. So if we take an example, in case of standard deviation, in case of ungrouped data, so formula is sigma x square divided by n under root. And suppose these are the values, these are the 5 scores. So we just calculate the total is 50. 50 divided by 5 is our mean value. So mean for this case mean value is 10. So deviation from mean value for each score, so this is the formula for x. X means small x means deviation from mean value. So 6 minus 10 is equal to minus 4. 8 minus 10 is equal to minus 1. So this is the way we calculate the x value, and after that we calculate the x square. So x square value is for just only we use this process to ignore the sign, to manage the sign in standard deviation. And after that we have the value of total of this is 16 plus 4 plus 0 plus 4 plus 16, so its total is 40. So 40 divided by 5, so is the average of our deviation from of a square. And to manage this square we just take the under root of this entire value. So now our standard deviation is 2.83 for our ungrouped data. This is the entire process of calculation of standard deviation through ungrouped data. But in case of group data, suppose we have a group data, so first we need the mean value. Without mean we are not able to calculate the standard deviation. So in case suppose this is the data, most of the time we have a data in an interval scores. So first of all we calculate the midpoint, and these are the frequency. So process of calculating mean is so simple. First of all we calculate the mid value and frequency, and we calculate the fx value. So it's called the fx value. So fx multiply by frequency multiply by our midpoint. So this is the fx, and the total of these divided by the total of frequency. So this is the mean value. So mean value for this data is 119.44. So in this case, so we have the mid value, frequency, and now we calculate the x, means the deviation from our mean value. So in this case 137.5 and 119.44. So if we calculate, the difference between these two is 18.06, is positive. Okay, and this case we just calculate the differences, again the minus 119.44, and the difference between these value is 14.06. So after that we calculate the fx. Fx means this is deviation and the frequency, the multiplication of these. So now we need the x square only. We are not required to fx this entire whole square. Now we calculate the fx square. So only x, so multiplication of fx multiply by 18.6, yani x value only. Okay, so this is the fx square. So as per formula, now we have fx square divided by n. So sigma of fx is 8927.29. So divide by 200. This is the 14.64, and the standard deviation for this value is 6.68. This is the entire process of calculation of standard deviation on ungrouped data as well as group data. So now we just discuss the uses of standard deviation. First important uses of standard deviation is when statistic having the greatest stability is sought. So in this case, stability I already mentioned. So mean is the again the mean is the again the stable measure of our central tendency, and the standard deviation based on mean value, so it's called, that's why it's the standard greatest stability is found in standard deviation. When extreme deviation should exercise is a proportionally greater than effect of the upon the variability. So extreme deviation is not required, and the when coefficient of correlation and other statistic is subsequently to be computed, so we use standard deviation. That's why mean and standard deviation is a very popular terminology generally we use in our researches. So thank you for watching this video. If you have any doubt, any query, you can ask any question through comment box. For this entire thing I use the Garrett book. If you are interested, you just go and see the Garrett book. You find everything in Garrett book as well. Thank you so much for watching this video. Please like this video, subscribe this video.